Let's discuss this question on heat transfer. We are asked to find out basically the steady state temperature profile is given in the composite slab, and we are asked to find out which material has thermal conductivity. So recalling that the conduction Fourier law, the steady state temperature distribution in a slab is given basically by Q is equal to K. Let's say for the slab A, Ka, suffix A is basically for the material A. K, I'm just writing about the Q flux actually, so let's put a double star here. K and dt by dx for the material A, and for the material B it is Kb dt by dx for the material B. Okay, so writing this in a steady state distribution form, both of this has to be equal at point 2, which is the interface, the steady state distribution has to be equal. So Q double A has the heat fluxes have to be equal because there is no gap conductance or something like that. So heat flux has to be equal. So how do you write? Another thing which I want to point out here is that the heat flux, there has to be a sign here which has to be included here. So let's go by that. So minus Ka dt by dx is basically, if you recall the figure, it is T2 minus T1 by H2 minus X1. H2 minus X1. So this is the slope, and QB is minus KB, T3 minus T2 by H3 minus H2. So going from the figure, you can see that T1 minus T2 by the length is tan 30. For the first, from the geometry of the first figure, I can write T1 minus T2 is the length on the y-axis by H2 minus H1 is the length of the x-axis, that is tan 30. Okay, so T2 minus T1 will become tan 30. Now I am just providing you a mathematical solution, but physically also, without doing all this, you can just get to the answer. We'll see in a bit. And minus KB. The second one, it's minus tan 45 because T2 minus T3, T2 is bigger, so T2 minus T3 by H3 minus H2 is tan 45. So by this we come to know that Ka tan 30 is Kb tan 45, which is 1. So from this I get to know that Ka is Kb by tan 30, and tan 30 is less than 1, so Kb by less than 1 will be greater than Kb, and therefore Ka is greater than Kb. So material A has higher thermal conductivity, so the option is A. Now before this, if you don't want to do all this maths and you want to get to the answer directly, you should understand that an insulator has a very low thermal conductivity, and there's a steep change. There's the temperature difference across the insulator slab will be very huge, and in opposite to this, if you have a superconducting slab or a material which has a very high thermal conductivity, the temperature change across the ends will be very, very less. So going by this, if you look at for the same length of the slab A and B, the temperature change looks to be more in slab 2 than slab 1. The temperature change that is clear from the slope, right? The slope in the slab 1 is 30 and the slope in the slab 2 is 45. So there's a larger change of temperature in slab 2, whereas the lengths are same in both the slabs. So 2 obviously is something like an insulator when compared to material A, or the other way of saying it is that material A has a higher thermal conductivity than B. So this is from the physics point of view, but if you want to just do from scratch, this is what we have done. Equate the heat flux at the interface, and from the basic definitions, you can just get to the answer. So option is A. Thank you.